What are the two main types of bipolar junction transistors and how are they structured? There are two main types of bipolar junction transistors. One is NPN transistor and second is PNP transistor. In NPN transistor, the P type is sandwiched between two N types. In PNP transistor, the N type is sandwiched between two P types. There are three terminals in case of transistors. One is emitter, base and collector. In both the types, the base is sandwiched between emitter and collector. What role does the emitter play in functioning of a BJT? The emitter in case of a BJT is heavily doped, which behaves as a source of majority charge carriers in the transistor operating. The majority charge carriers in NPN transistor are electrons, whereas in case of a PNP transistor, they are holes. Due to forward bias, the majority charge carriers from emitter are moved in base and further in collector, which leads to the current amplification. Thus, emitter is an important terminal in the amplification of current. How do the three primary transistor configurations differ in their applications and performance? There are three primary configurations in case of a transistor. They are common base, common emitter and common collector. In all these three configurations, one of the terminal is made common for input and output. Common emitter configuration provides high current gain and voltage gain, makes it ideal for general amplification required. Common base offers high voltage gain but low current gain, suitable for high frequency applications, whereas the common collector configuration provides high current gain and low voltage gain, used for impedance matching as it provides low output impedance. Describe the three operating modes of BJT and what each mode signifies. The BJT has three operating modes, which are also called as the regions: active region, cutoff region and saturation region. In active region, the base emitter junction and the emitter collector junction both are for forward bias and reverse bias respectively. This mode is primarily used for amplification as it allows current amplification. Cutoff mode: in this mode, both junctions are reverse biased. The transistor is practically switched off and no current flows from collector to emitter. Saturation region: in this region, both the junction base emitter and emitter collector junction both are forward biased. The transistor is fully on, which behaves as a closed switch and allows maximum current flow in case of a transistor. Why is thermal stability a concern in BJT applications and how it is typically managed? The thermal stability is crucial because BJT are sensitive to temperatures, which can affect the operating point position on the DC load line. If temperature is increased, the collector current can also increase, which leads to the shifting of Q point in the upward direction, due to which the position of operating point can shift from active region to saturation region. This kind of shifting is managed by using temperature compensation techniques, using diodes or negative temperature coefficient thermistors in biasing network. How does the voltage divider bias improve the stability of BJT's operating point? Voltage divider bias uses a pair of resistors to create a stable base bias voltage, which is less dependent on transistor's beta value and external conditions such as temperatures. The voltage divider network is formed by two resistors R1 and R2, which provides a fixed voltage to the base independent of transistor characteristics and provides an operating stable point. What are the advantages of using a BJT? The advantages of using BJT are: BJTs have high current gain and can operate at high frequencies, suitable for a wide range of applications from audio devices to high-speed computing. The disadvantages are they have high power dissipation, they are more sensitive to thermal instability, and requires continuous base current to operate, which can be less efficient in terms of power consumption. List the applications of transistors. The transistors are used in various applications such as amplifiers for amplification of signal, Switching devices where we can be used to turn on and off the device, voltage regulation to provide the constant operating voltage, oscillators to provide continuous oscillations, audio devices for audio amplification, signal modulation. It is used in sensing and detection circuits. It is used in computer memory. It is used in power control, in automotive electronics, and many more applications.